This is a little bit of a talk on kind of pivot points and local versus world orientation. So let's go to Maya here. And in the 3D space here, you can see at the bottom left of the viewport and perspective, it's going to show me what Maya's kind of world concept is. So Y is up, X positive is this way, and Z positive is that way. Okay, so in Maya, whenever you create a lot of objects, for example, a NURB circle, okay, first of all, as I activate my transform tool, which is the move tool, generally it will put it at 0, 0, 0 in world space. Now you'll notice if I hit my rotate tool that the it's essentially going to, it doesn't know, why would it give it a different orientation? It's just going to be the exact same thing as the world, right? So Y is up, and you can see that right here. This little green circle is Y. X is on this axis right here, pointing that way. And then of course the Z is this way, and you can see that here on this Z axis right there. Just bear with me. So let's move that over, create polygon. It doesn't matter anything. Let's just do like a gear, for example. So again, it's going to put it right at 0, 0, 0. Same thing if you activate the rotate tool. Its local orientation is the exact same thing as this, as world. Okay. Also pointing out the pivot point is right there in the center of the object. I'm just moving it over. If you create something like a camera or a light, even let's make a directional light. Exact same thing. It even has a local orientation of its own. Create camera, boom, pivot point 0, 0, 0, just puts it right there at origin. And excuse me, the pivot point is there at that part of the camera. The EP curve tool, if you draw this out, which hopefully at this point you've seen this before, so you're just clicking points on this grid, and if you hit Q to end the tool, well, surprise, surprise, the pivot point, it doesn't know where to put it. I mean, I guess it probably could to default maybe some center point between it all, but it's just going to put it right there at 0, 0, 0. And of course, you can move your pivot point. You can move on a Windows keyboard. Insert will toggle that on and off, and you can move the pivot point around. On a Mac, that's the home key. You can also hold hotkey D, and in my case, I'm either going to do point snap, which is hotkey V, or X for grid snap. So that's D and V at the same time, or D and X at the same time, and that's just moving the pivot point. If you make something like a locator, so Maya's gonna create it at 0, 0, 0, and the pivot point of the object is going to be right there in the middle of it. Okay, it's just important to kind of be aware of that. So let's make a joint now. This is a little bit different. So when you create a joint in Maya, you just start clicking this on the surface, right? Like that. It's a little bit like the EP curve tool. So skeleton and create joints. So what you should note, first of all, is the pivot point is going to be wherever you place the joint, right? So pivot point, and so on. So let's just real quick activate my move tool. So the pivot point of this joint is right here. They actually have 4 joints here, and if you open this up all the way holding shift, you can see all 4 joints. So each pivot point is going to be where that little joint is, right? Okay. And sometimes in Maya you'll hear this referred to as the joint, and then the bone part is kind of, I guess that's kind of what you might call it, but it's kind of, I just probably tend to refer to it as a joint overall. Okay. So let's just continue that same conversation. So when so the same thing, I've got my joint tool active, and I'm going to place some joints. Now, what you want to pay attention to is each time I am placing the joint, it's going to orient to the next joint, or it's going to orient toward its child. It may not be very easy to see right now, but this joint is actually just oriented to the world because it doesn't know where else to be oriented to. So when I place this next joint right here, for example, and then when I release my mouse, you'll see that this one is going to actually orient towards this one. The same thing. This one right here, it does not have a child. It doesn't know where to point. So it's just going to match the world so-called orientation, as it were. So as I come over here and I place, let's just zoom in a little bit. Maybe we can see it a little bit better. I'm going to go ahead and my joint tool is still active. And if I just place another joint right here, this is going to orient bang, bang right at it. So let's click and hold. Okay, and now as I release my mouse, boom, you can see that it kind of orients itself over this way. All right, so let's just have a look at that to be a little bit more specific. So let's select this joint, and I'm going to go to Display, Transform Display, and Local Rotation Axis. So hopefully you've seen this before, and if you haven't, you'll see in rigging you'll see this quite a bit. But it's under Display, Transform Display, and Local Rotation Axis. So let's just activate that. So what this shows us is that, okay, this X is pointing down the joint chain to its child, to the next joint. And this is totally different than the world, okay? Let's go to this one and just go to Display, Transform Display, Local Rotation Axis. Same thing, so it's just pointing in this direction. And these are gonna be, they'll have their, their own local rotation axes as well. If you go to this one, you'll notice, so these are not the world. They don't match it at all. But this one right here, you can kind of see there's like a little preview inside there that it does. So if you go to Display, Transform Display, Local Rotation Axis, bang. Okay, so this one, there's no child, there's not another joint in this chain. So it has no idea where should it point. So it's just going to be like, I'll just be world. These all know where they're pointing, but not this one. So the basic conversation right now is basically we have pivot points, right? Yeah, and then we also have some sort of orientation. If you don't tell an object how to be, oriented, if I can say that word, then it's just gonna match the world, and that's it. So let's go to create like a, I don't know, maybe like a pipe is fine. It doesn't matter. So if you put it there, it's going to place it at 0, 0, 0 again. The pivot point is, is in the middle of this object. And if you hit the rotate tool, you can see that it's matching world. If you go to Display, Transform, and Local Rotation, it's just going to show you that I'm going to scale that down so we can see it a little bit better. The local rotation on this is the same thing as world right here. And hopefully, like if I move this over, you can see that these two are not the same. This one is just, again, it's just the exact same thing as world. And that joint is off. It has its own kind of local thing. All right, now the conversation of why you want this, it's a little bit of a different one, or why you wouldn't want it, or whatever, but it's actually quite important. But I don't really want to, it's kind of more of an animation thing, like in the graph editor when you're working with your curves, you want to be able to edit like in a specific axis, rather than just whatever. So joint orientation is very important, but it's sort of right now maybe a different conversation. The main thing right now is I just want to talk about pivot points and that local orientation, and kind of how it works and what it means, and how to work with it. Okay, so let's just real quick, let's just go to create joints. So I'm just going to click here. This is sort of like maybe what an arm might look like in in our world. Okay, so I have 3 joints. I have 4 joints actually. You can open them all up right here. Okay, so I can go ahead, same thing. I'm going to go ahead and go to Display, Transform, Local Rotation Axis. Okay, so that's pointing down. All right, so if I want a controller for this, let's just say I want to have like an animation control, or you might call it a rigging control. I'm just going to create a NURB circle. Maya is going to plop it right there again at 0, 0, 0, right there at origin. The pivot point to this object is right there, dead center. That's it. Now, I can move this in space. The pivot point is going to stay with it, right? Yeah, let's just worth noting. Let's just make a group. I'm going to do just, I have nothing selected. I'm going to do Control G. So similar to, you know, when you create NURBS, primitive, a light, a camera, a locator, and so on, it doesn't know where to put it. So it's like, okay, we're just going to go 0, 0, 0. So even though you can't see this null Control G, it's actually there. And if you hit move, it lives, and you can see it's updating over here and the thing, even though there's no, you know, sort of like a disembodied spirit or something. It's just kind of, you know, it's just kind of information, so to speak, as it travels through 3D space. And these values are based off of, you know, relative from this position. If you zero this out, it's just going to go right back like that. Okay, so now if I move this around, I can hold hotkey, I can snap to my grid, and I can snap to points. Hotkey X right here is grid snap, and hotkey V is point snap. Hotkey V, in my mind, I kind of think of that as like, let's see, sorry, hotkey V is point snap. I was hitting C there just now. Sorry about that. So point snap. In my brain, I kind of think of this vertex snap. This will snap to like polygon vertexes, but this won't actually snap to, in this case, anything else. But right here, we're snapping to joints, which is totally fine. If you hold hotkey X, it's going to snap to grid, right? And of course, as you move it through 3D space, it's gonna update, you know, translate X or translate Z or whatever. So it's important to be aware of that a little bit, okay? Now, I can also use Maya's modify match transformations. We have match translation, match rotation, and scaling, and that kind of thing. All right, so if I have this selected, and then I shift select this, and I go to modify and match translation, this is gonna just pop to that same pivot point location. Let's try it. Modify, match transformations, and match translation. Boom. So it just pops right over there, right? Okay, cool. Now, yeah, and you could do it here too, same thing. So modify, match, translation, and so on. So now if I want to use this as, say, a controller for this, I can do that, and this is standard. That's how you normally do it. Holding V, I'm just going to move it over here, and now if I want to, if I wanted to rotate this over, you know, maybe scale this up even, but I want to rotate it over so it sort of matches. Like if this was an arm, for example, there's geometry in here. I can rotate it over and, you know, try to eyeball it to get it into place, because I want this to, that's just the way that I like to do controls. It's pretty common. You can get close, but it's not exact. If you want to match it exactly, you really need to use like match rotation. Okay. Now it's important to pay attention. Right now we're introducing all of these garbage values right now. You know, usually on a rig, you really want to have, the your rigging controls, you know, translate and rotate should be 0, and, you know, scale would be 1. This is very important. Now, if I happen to, yeah, so that's why you freeze transformations. Okay, so if I freeze on this right now, that would clean all of this up for me. Okay, and that's what I want. Okay, let's freeze on it. Okay, now the problem that I have is that the local orientation of this NURB circle is world. Okay, because I froze on it. And the joint here, its local orientation is, again, X is down. I can just move this over a little bit, and let's just go to display and transform display local rotation axis like that, right? So you can see this thing is rotated off to the side, but its local orientation, so to speak, is just the same thing as the world. This is very important. Anyway, I'm going to hold V and just snap it into place. You can see these two transform. What do they call that? The local rotation axis. They don't match. Okay, they're different. Now, if I want to control this joint using this as my rigging control, well, we often use what's called like an orient constraint, for example. So let's just go ahead and select this, shift select the joint, and we'll go to a constraint and we'll use an orient constraint. Okay, so let's do it. Bang. All right, so what happens is the joint is now, it's going to match whatever this was, and this is, matching world rotation. So it just pops right over. You can see those two local rotation axes now. They're exactly on top of each other. I don't want that joint to rotate over at all, and I also have these, I have a constraint on it. You can see that in blue right here. But I also have this garbage information, this -34, which I don't want that on a joint. It's okay to have translation information on a joint, but not rotation. You want these to be 0. It's kind of another conversation, but just bear with me. Let's undo that real quick. All right, so if you wanted to try to match these two together, well, then what do you do? Okay, rather, more specifically, you want this local axis to match this one, the local orientation. Okay, well, we have this modify match rotation, and that what will that give us? Well, let's select it and shift select the joint, modify match, and you can do match rotation this way. Boom. Okay, which you should see two things. Well, the local transform right here, now they match. Okay, well, it also rotated our circle over. Okay, well, I don't know if you remember, but I had tried to rotate this thing around to kind of line it up if there was a joint in here, or there was geometry, there was an arm in here, an arm model. So that doesn't really help us very much. Okay, so let's just leave that there for just a minute. I'm going to go to create NURB circle. Let's make another one. Okay, so if you make it, it's just going to pop it there at origin circle. Okay, so what happens if let's just call this like X control. Okay, and if I group this, Control G, it's in place. Of course, what's going to happen is it's going to give us a group on top. If you open it, the X control is still inside of it. This is the child, and this is the parent. If I move this group, the child is going to follow along. The pivot points are still exactly the same. This is incredibly important. Okay, now what I had done before is moved this one over into, I just used vertex snap, and then I used modify and match rotation. And that's cool, but I'm sort of getting this thing all rotated off in a weird way. Well, with a group above it, we usually I'm going to copy this name and do offset group like that. So now I have this little node above it, right? Well, if I use that to match, let's see what that does. So I have it selected. I don't have the control selected. I have the offset group selected. Let's shift select the joint, and let's go to modify match translation. Okay, boom. Okay, so now their pivot points are in the same location. Okay, very good. Now, again, same thing. So the group, not the control itself, but the parent above it, and then the joint, and let's go to modify match rotation. Boom. Okay, that's a bad example. I want to undo that because I forgot to do one thing that's important to show. Let's go on this. I think let's go. I just want to turn on the local rotation axis, right? I want to show that. You could do that really with the group or the control in this case. because they are the same. They're both world. But I guess let's just show the control itself. I don't know. Let's just do it on the group because that's what I'm going to be working with. But let's go to display, transform display, local rotation axis. There it is. Okay. So now what I want to do is just use my transform, my matching tools, and just get it on that joint right there. So with that selected and shift select the joint, modify, match, translation, boom. Okay, there we go. That's what I was trying to show. So now the pivot points are in the exact same spot of both of these, right? Okay, pivot point, but local orientation is different. So, so select the group, shift select the joint, modify, match, rotation, boom. Okay, cool. Now the local rotation of these the local orientation is exactly the same. This is what I want. Okay. If you select this offset group, what is happening is it's actually storing this 34.382. And if you select, which is what I want, this is the job of this offset group. The control itself is clean. There's nothing on it. Okay, now this isn't very helpful because it's perfect in it. I could constrain the joint now, no problem. However, visually, this may be less desirable just because if there was a model arm on here, for example, I just want it to be rotated right like that. What I can do is probably now, because of the way things are kind of set up here, should be able to make this like 90, rotate it Z and 90, and get it perfect, perfectly up like that. Cool. And of course, in this case, I have a little bit of a value here in rotation, and I've scaled it up. So I need to freeze now on this thing. So let's go to channel, freeze all. Okay. And so I have my offset group with my garbage information here from the joint, which is this is good. That's its job. The control now is frozen. It's nice and clean. This is good for animation. And what I'm also going to do is, again, you can see the pivot point of both of these is exactly the same. The local orientation of both of those is exactly the same. So what this means now, if I go to my control and shift select my joint to make a rigging control and go to constrain and orient, boom. So now what this does is the joint does not move or anything like that. The joint doesn't get any additional garbage values in it. This stays at 0. The rigging control itself is there. This is also 0. And if you select it and rotate it, it's manipulating the joint the way as expected, because that's what an orient constraint does. Also, if you look at the rotate tool itself, this is not specifically, this is probably the very confusing part, but the world is over here, with Z going like that, Y going up, and X going this way. But this right here, this control, is exactly the same as the joint. So we get this kind of behavior, right? So the exactly like that, and you can see the x-axis this way. So when you're animating, this is very desirable. I don't want to animate a finger or some other thing according to world, because it becomes really hard. It just doesn't make any sense. So that's why you want this kind of local thing. But all this is coming from is just essentially we use this is the tool that we use, the matching rotation, to get it. There's other ways to get it, but the point being is that they're the same. The joint has its own local orientation. It's not world, and that we match the control curve first. So that's very important. Now let me delete this real quick. I just want to make one other little point worth noting. Let's go to create NURB circle. Okay, let's call this the same thing, X control. All right, and let's Now I'm gonna group this 2 times, and of course the pivot point is 0, 0, 0 at origin right there. Let's group it twice. Control G, Control G. Okay, all right, so there it is. So now we have 2 so-called offset groups, and I always do 2. This is common in rigging. You'll see a lot of riggers do this. Okay, so I have offset group 1, double click copy, double click paste. So we have offset group 1, and control. So the top offset group, so if you move it around, the entire hierarchy moves along with it. Okay, this one is going to store my garbage values, the top one. This will leave me with this additional garbage group, or a so-called offset group, that's just going to, you know, I can do whatever I want with it. It's going to be clean. There's not going to be anything in it. And then of course I will have my rigging control itself at the bottom of this hierarchy. So what I'm going to do is select the top offset group. I'm going to shift select the joint. I'm going to go to modify, match transformations, and let's do match translation. Actually, first, I apologize. Bear with me again. So on that top offset group, let's just go ahead again, display, transform display, local rotation axis. The reason I'm turning it on is just so you can see it, and hopefully it's a little more clear. And again, I have to emphasize this concept is really important. It's very useful and helpful, but it's just, frankly, it's one of the most confusing, discombobulating things that, you know, that we deal with. So this is the offset group. Let's shift select the joint, and then let's go to modify, match transformations, and let's do start with match translation. So we'll see it move over, and the pivot points are in the same spot. By the way, again, just to reemphasize this, the pivot point of all 3 of these offset groups is identical, and the control and the joint, they're all 3 the same. All right, back to my top offset group, shift select my joint, modify, match transformations, and we're going to do match rotation. Boom. And there we go. So you can clearly see that the local rotation axis of this little system right here is matching exactly the same thing as that joint. Now, okay, again, just to get back on that top offset group, it's storing these so-called garbage values. This is what I want. This is its job. Going down into that next offset group, this is 0, clean, and this is just going to be kind of sitting here, and I'll use this later for other things if I need them. And going on down to the rigging control itself, here it is. I see it. Great. This is zeroed out too. Again, little problem. I probably, there's a good chance I want this rotated over, and I could probably do that Z and 90. Bang. Even scale it up a little bit. This is how I did it before, and I can freeze on this. So let's just go to freeze and do freeze all. Bang. So the rigging control is zeroed out. Good. So now it doesn't actually manipulate the joint, but I can go ahead and select it, shift select the joint, and put an orient constraint on there. Maintain offset is off. That's what I want, and just go add. Boom. Now what I have is this. I have a rigging control that perfectly matches my local orientation of my joint, and I get these nice, wonderful ways of animating, right? So the lateral axis there, it's going to be just relative to this just local little joint. So again, this concept, this is the hardest thing, but definitely one of the hardest things that we kind of deal with, I feel like, and hopefully this little primer sort of demystifies it a little bit. I've been looking for ways to kind of explain this for a long time. Hopefully this is helpful. Thank you very much.